Hello guys, welcome to AR Tutorials. Today is day 31 of solving Leetcode questions daily. Friends, today we are going to see another question related to the binary searches, and it would be a continuation part of the yesterday's counting the first and last occurrences. Yesterday we have discussed how to calculate the first occurrence, similarly how to calculate the last occurrence. There we are going to return the index, and now just we have to give the count, that what is the count of highest number of occurrences. So in this question, first let me take out. Okay, so okay, let me just zoom. Okay, so what we have to do here, we have given an array. This is our array, and here we have given the it is the length as 2, and we have given the element as we have given the size as 7, and we have given the element as 2. We have to tell what is the occurrence number of 2, that how many times it has been occurred. It is very simple logic because we have already discussed it. If, my dear friends, if I calculate the first occurrence, if I calculate the last occurrence, I really know how much is the starting index and ending index. So what I'll do, I'll just add on this, because starting index will give me the first occurrence and end index would be give me the end occurrence. So if I minus them and I add plus 1, because why? Because index starts from 0. 0 to n minus 1 we traverse now. So if we want to get the actual position, we'll just do one thing, that we'll just first we'll calculate the lower bound, we'll get the first occurrence, then we'll calculate upper bound. We have calculated. Now do one thing, that we'll always upper bound will be greater, because upper bound index would always be larger. So what we'll do, we'll just subtract upper bound minus lower bound, and we want position, we don't want index. So what we'll do, we'll just add on 1. So let's dry run it. First we'll just dry run it and we'll see. So let me mark the positions. So this would be 0th, 1st, 2nd, 3rd, 4th, 5th, 6th. Now friends, I hope you know what is lower bound and upper bound. If you don't know, I'll just give you a quick reminder. If you really want to learn these topics, I have a plenty of questions solved on these topics, and I have also made a detailed video with regards to lower bound and upper bound. I'll just tell you what is lower bound. Lower bound just notifies what is the first occurrence of that element in the list, and upper bound just gives the first occurrence which is greater than that element. That means if what is the lower bound of 2? Of course you should know that upper bound of 2 is 3, because it only depicts greater than symbol, and while lower bound depicts greater than equal to. So for lower bound, if we calculate 2, so what will give? He'll give me 2, sorry, it will give me the first index of this 0, 1, 2, second index, and if upper bound is concerned, it will give me the third, that is the 6th index. So we want to subtract it just, and I have also told you the technique how to find upper bound with the lower bound function only. So it will just reduce the complexity of writing the code. Just what we have to do, instead we were getting this element as the upper bound. Instead what we'll do, we'll first find the lower bound of second index, and we'll find the lower bound of next element, that is the third element. So what we'll do, we'll just shift the pointer to here, and we'll get the exact range, that where my element is lying, and I'll get this exact range. I'll just subtract it from my whole length, and plus 1 will give me the exact position variable will be there. Instead of doing all those stuff, we'll just calculate the upper bound, we'll subtract the lower bound from it, and we'll just add 1. So this is the simplest logic you will ever find. So let's see the code. If you don't get the code, I'll explain it again. So let me just take out my pencil. Okay. So what we have done, low and high, we have set it. So when we have set low and high, we'll just iterate low is greater than high until and unless the high crosses low. So we have calculated the mid. Very easy formula. This formula also works. Low plus high minus low plus mid, just because we don't want to get into some stages where low plus high by 2 crosses or exceeds the integer values. Then what we'll do, we'll first make sure that high is minus low. It will give you a small integer, and we'll then plus add. Just it's a base condition, not very much necessary, but it's a good practice to solve the codes with the edge cases. So that's a good practice to write this formula to find the mid. Instead, there would be no such issue when you solved a low plus high by 2. No such issue. Then we'll just normally check, as we check in binary searches. We'll just check my mid element is greater than x. X is given to me. Then it is a lower bound function, so greater than or equal to. Then my answer I will count and just shrink the search spaces. If not valid, it will shrink. If my number is valid, it will be stored in the answer. So this is a lower bound function. Now here comes the interesting part. What we have to do, we have to first find the lower bound. So we have called lower bound, and I have told you upper bound. So upper bound, there is no need to write the function. What we will do, we will just do x plus 1. Whatever my x is there, it is 2. Whatever it is there, it will just plus on it, and plus on next element, it will find that, because I have told you that if that element is not present, if for example my array consists 2, then directly 5, there is no 3 and 4, then how the upper bound will work? If upper bound of next element is concerned, that is 2 plus 1, 3 upper bound is concerned or lower bound is concerned, what you will do, if they are not present, they will find nearest possible way which is greater than that. So automatically 5 will be there. So this is also completely valid, because we are finding lower bound of the next element. If that next element is not present, it will find that nearest possible way which is greater than this number. So automatically it will return you that exact number. And what we will do, we will just upper bound minus lower bound plus 1. Plus 1 logic I have told you, because we are getting size, we are getting index, we want size. So for that sake of concern, we have added 1 to it and we have returned. This code is very optimized and very minimalistic, because all over the logic is involved, and using only upper bounds we have solved this question. So I'll just run this code once. This might be running fine. Because logic is overall correct, there is no such ambiguity in the logic. We know what we are doing. So yes, we have got a good answer with all test cases passed. So thank you guys for watching this video. I hope you have liked the video. Please do like, share, subscribe to my channel, and if you're new to this channel, please share my channel and please support me. Thank you.